Gravity is the fundamental force that anchors our existence. It acts as the invisible glue that holds planets, stars, and galaxies together in a delicate cosmic balance. The mathematical foundation of this interaction is Newton's law of universal gravitation. It dictates that the strength of gravity is directly proportional to the masses involved and inversely proportional to the square of the distance between them. Distance is critical. As distance increases, gravitational force diminishes rapidly, following the inverse square law. This precise relationship is what keeps planets in stable, predictable orbits. In our universe, gravity is a constant. This stability allows structures, both atomic and astronomical, to flourish. But what if this glue were to shift every single day? Gravity is governed by the Newtonian law of universal gravitation. The force of attraction depends on the mass of two objects and the square of the distance between them, tied together by the gravitational constant, g. In our universe, g is constant. But in this scenario, if g were to fluctuate, the entire fabric of physical attraction would shift instantaneously. Imagine waking up to find g has doubled. Your body weight would instantly double, putting massive strain on your skeletal structure. Conversely, a drop in g would make you feel weightless, leading to atmospheric drift. This mechanism requires a fundamental shift in mass density or the gravitational constant itself. Without this stability, planetary structures cannot maintain their integrity. If gravity were to increase, the atmosphere would compress rapidly. This sudden compaction causes the temperature to spike through adiabatic heating, creating crushing pressures. Conversely, if gravity weakened, the atmosphere would expand and drift into space. This leads to rapid cooling and the loss of life-sustaining pressure. Man-made structures are designed for constant, predictable forces. Gravity usually provides a steady load, but in a world with variable gravity, this stability vanishes. A mere 0.01% daily change in gravity would induce cyclic loading stress. This forces materials to expand and contract rhythmically, leading to hidden microscopic cracks. Without a constant gravitational baseline, these materials experience accelerated metal fatigue. Over a period of just a few weeks, this constant vibration-like loading causes structural systems to fail completely. In this extreme environment, the structural integrity of our world would literally shatter, making long-term habitation impossible. Evolutionary biology relies on stable environmental pressures. In a world with variable gravity, the internal load-bearing structures of complex life, such as bone and tendon, would face catastrophic stress. To survive, life would favor low-profile anatomy. By minimizing the leverage gravity exerts on the body, organisms could avoid skeletal fractures during sudden spikes in gravitational force. Speculative biology allows us to model these extremes. Creatures like the flowerjaw adapt to low-gravity states, while a high-gravity survivor might evolve insectoid, multi-limbed skeletons for distributed weight support. Without a stable gravitational constant, these extreme anatomical blueprints would be the only way to avoid biological extinction. Ultimately, a world with changing gravity is a world without equilibrium. Earth exists in the Goldilocks zone, where stable gravity ensures atmospheric retention and climate balance. Stability is the foundation of structural integrity. Without it, mechanical equilibrium fails, preventing the formation of complex biological and physical systems. Scientists conclude that the extreme, unchanging nature of Earth's gravity is the condition that allowed complex life to flourish. Stability is the foundation of our entire existence.